Okay, can you see the slide? Okay, for today's lesson, we will look into the retrieval evaluation. In lesson number 4, you um, learn how to quantify the similarity between the query and also the document, right? And also you learn how to do the ranking. Um, so different query will give you different results. So in order to evaluate the performance of the system retrieval, we need to have some benchmarking or some kind of mechanism to measure how well is the system designed in order to retrieve the document. So we will learn how to evaluate the retrieval system. So we will use two reading or two measurement on how we can measure the quality of the system retrieval. So this is due to the fact that for every one of us, we will measure or we will provide feedback depending on our background. So if you have enough background, then you will be able to provide um, feedback related to degree of relevancy of the document written to you. But if you do not have any background knowledge, so it is difficult for you to provide feedback. So for that reason, different people will give you different interpretation about the relevancy of the document. So for that reason, we need to have some kind of metrics or measurement we can use to measure the quality of the system retrieval. So without proper retrieval evaluation, we cannot determine how well or we cannot compare the performance of the IR system. So this lesson or this chapter is a very critical and integral component of any modern IR system that we have. So we should be able to um, assess or evaluate the performance of the retrieval system based on the result written on several query that given to system. So describe the process of evaluation, we should have this reference collection. So we should have a set of D of pre-selected documents. So this is all the document that we have in our system, pre-selected document. And we also have the information related to the query. So we have information related to the query. This is the one that we are looking for. This is the information that we um, require to get from the system. So at the same time also we need to have a set of relevant judgment. And this is to say that the information given to you can be related to the document that you have. So if the judgment has a value of 0, if the document belong to document J that belong to the pre-selected document uh, is not relevant to the information that you require here. And one otherwise means the document or the J document here has some kind of relevancy with respect to the set I of information that you require. So these judgments are produced by human specialists. They are called human specialists because they have a good background on the subject that we are discussing here. So when we talk about the concept here, the set of D of pre-selected document, the query, and also the judgment whether the document is non-relevant or relevant. So we have to look at two things here, precision and recall. So this is what you will be learning, the retrieval matrix, and also single value summary. So single value summary, normally we are looking at one value that can summarize the whole scenario. Okay, let's take a look at the precision and recall. So to describe this assessment, we have to describe what is the overall situation that we have. Okay, so let's consider I be the information requested. So depending on your query, so I is what we want to have, and we have R. R is the set of relevant document for the query or the information that we have, and then A is the set of information produced by the R system. So if you look at the map here, we have R relevant document. So these are the relevant document with respect to I, and we have the answer given to you. So it could be consisting of not relevant and relevant document. So what we are looking at is to maximize this overlapping here. So the big circle is referring to the selected document D. So the objective is to maximize this one. So based on this description, we can describe the position and also recall, and we will look at the formula based on this diagram. So if we look at the recall first, so the recall refer to how many of the relevant document can you retrieve. So that's why we are looking at this intersection here. So how much the section of answer can cover the relevant document here. So this recall is the fraction of relevant document being retrieved. Okay, so that's why bahagi di sini or the divider here is the number of relevant document. In contrast, if we're looking at the precision, we're looking at fraction of the retrieved document which is relevant. So we are looking at the portion here, how many of document are relevant. So we want to maximize the overlapping here. So we want to know how much area you cover here with respect to the answer. So that's why the divider here is the number of retrieved document. Okay. So let's take a look at how do we apply this calculation, recall and precision. So normally we will look at the curve of precision and recall in order to look at how good is the retrieval system. So at a certain point in the retrieve document, we can measure the precision and recall. So it depends on which position that we are talking about. So given this reference section and a set of test query, so we are looking at this query 1, and this is this indicate relevant document with respect to query 1. So we have 10 of them. We have 10 of them. 10 documents which are considered relevant to query 1. This is given. So let's suppose we have this IR algorithm and the sequence or the ranking of document that returned to you are in this order: 1 to 5, 6 to 10, and 11 to 15. So the dot mark here indicate that that is the relevant document found in the list. This is based on this list. Okay. So now we can look at the precision and recall. So how do we actually compute the recall and precision? So we just look at the mark here. So for us to compute the precision, we look at the recall first. So the recall refer to how many of the relevant document are being fetched or retrieved at that particular point. So when we are here, at this position, the recall rate will be 1 over, because we have 10 document here. Okay? And our precision will be, at this point, will be 1 over 1, because we only have one document, and the one document is 11. So 1 over 1. So next one, we go to the next one, which is this one. Okay, at this position, the recall rate will be, because it consists of this, so the recall rate is 2 over 10, right? And what is the precision? It's 2 over 3, because we have 3 documents here, and 2 of them are relevant. Okay, now we are here. So what is the recall rate here? What is the recall rate?
Over 6. Yeah.
Recall rate is 3
Over 6.
No. Recall rate will be 3 over 10, because we are looking at
3 over 3.
how many of the relevant document that you able to recall. So recall always refer to how many document, how many relevant document that you are able to recall from the whole set of relevant document. So 3 over 10 lah. And then precision baru we say 3 over 6, because this one is
3 over 6.
referring to the answer, right? So this is the answer
Right.
given to you. And this is the set of relevant document that you need to recall. Okay. Okay. What about here? What is the recall? Okay.
Over 10.
4 over 10, right? So what is the precision?
4 over 10.
No, the precision is because we have, oh yeah, 4 over 10 also, right? So 4 over 10. So the 10 here refer to the number of document that being returned to you, right? Okay. Okay. Last one. What is the recall rate?
5/10.
5 of, yeah, 5/10. What is the precision?
5/15.
5/15. Okay. So we have all the value here. Okay, now what we want to do is we want to plot a curve, a precision and recall curve, so that by having this, we can accumulate the area under the curve that show the performance of the um, IR algorithm based on query 1. Okay, let's suppose we have, okay, this is the answer that we get. So this is the recall and position when we are here, and recall and position when we are here, and so on, here, here, and here. So with this value, how do we measure the quality of the, no, how do we plot the position and the position and the, okay, so how do we plot the curve? So we know that based on here, so the first one is 10, and the position is 100. So, and then when the recall is 20, the position is 66.6. When the recall is 30, the position is 50. When the recall is 40, the position is 40. When the recall is 50, the position is 3.3. Okay, so basically what we can do this one. So remember just now the recall 10 deposition is 100, the recall 20 deposition is 66.6, 30, 50, 40, 40, and 50, 33. So this value obtained from here, right? So as you have 10% recall, 100%. So we have that one. 20% recall, we get 66.6. And then 30% recall, we get 50. And then 40%, 50%, we get 40% and 33.3. Okay. And we do not have 60, 70, 80, so they're all zero here. So to make the graph nice, so normally we copy the 100 here upwards. Okay. So we plot the recall versus position curve, and this is what we get. So the idea is to have maximum precision 100 and recall 100. So our idea is to cover as many area as possible here. So we want to maximize this curve to cover more area. Okay, let's take a look at another example. Okay, so this is another example that we have. So this is query number 2. Query number 2 has this relevant document 3, uh, 56 and 1 to 9. So if we are here, what is the recall rate? What's the recall rate here?
1/3.
Okay, that's good. And what is the precision?
1/3 also.
1/3 also. Okay. So this one is actually 33.3, right?
Three, yeah, 33.3.
Similar to this. Okay, when we are here, what is the recall rate?
2/3.
2/3. What is the precision?
Precision is 2/8.
2/8. So this is actually 66.7, right?
2.7.
So this is 25, right?
25%. Yes, sir.
When we are here, so this is, what is the recall?
3/3.
100%. What is the precision?
3/15.
3/15. So what is 3/15? This is 1/5, right?
1/5. Yeah, 2%.
Okay, the problem now, you no longer have the 10, 20, 30, 40, 50 recall. So now what you have at the moment is 33.3, 66, and also 100. So if you want to do the table, so you have something like this. So this is your recall. This is your position. 50, 60, 70, 80, 90, and 100, right? So now we have this 33. Where's my mouse? So we have this 33. So it should be around here, right? So this one should be 33.3 lah, the position. So for the rest of this, we have to copy lah. 33.3, 33.3, and 33.3. This one is 66.7, so 66 is here. So the value will be,
25.
so we just copy the whole thing. And next one is 100. This is 20. So we copy,
20.
okay? So we will have this. So this is for query number 2. Okay, so for query number 2, we will have this. So this is the plot that we have for recall versus precision. Okay, so this area under the curve. Okay, so what we have at the moment is we have query 1 and query 2. Okay, to summarize the performance of the IR system based on query 1 and query 2. So what we can do is we can look at individual recall, and then we will take the average between Q1 and Q2. So this is basically we are looking at the precision of certain recall, and then we take the average. So if we have two query, this is query 1, this is query 2. So the overall performance will be, we take this value and add up them together and divide by 2, then you get. So same thing goes with the rest of the value here and also the value here. So we add up them together and divide by 2. We get this. So this is the average precision for each recall rate that we have. So this is the final assessment. So normally information retrieval, they are assessed based on several query. So in this example, we have two query, query 1 and query 2. Each query will have their own relevant document with respect to the query. So we take the precision that we have for each recall, then we the average, then we get this. So these are the final assessment, and this what we call it, the mean average precision will be the area under the curve. We will learn more about that. Okay, so by having this comparison, then we will be able to describe the ranking for two information retrieval. So basically, when we have this graph, so we want to compute area under the curve for the blue one, not including that. Okay, versus the black one. So we are looking at the black one. So that is this one. So by looking at the graph, we will not be able to determine which one is better. So we need to have a measurement. They call it MAP, or mean average precision. Okay, let's do another one. So this is like your tutorial. Okay, so we have this query number 3, and we have 4 documents. So we have this document, and this one, and that one. So if we want to plot the precision versus recall, so what is the value of recall here? So this is 1 over 4, and the precision will be 1 over 2. So for this one, the recall will be
Over 4.
2 over 4, precision
Uh, over 4.
2 over 4. Recall here is 3 over 4,
3 over 4. 3 over 4.
precision is
3 over 8. 3 over 8.
3 over 8. So over here, recall is
4 over 4. Understand?
100, and then the precision will be
4 over 13.
13. So similar to what we have before, so you have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So this is what? 25, right? So the recall at this stage will be 50%.
50%.
Okay, for this one, so for this is the recall at 50%. So
50%.
50% as well.
Yes.
At this stage, so this is 75%, which is here. So this is 3 over 8.
Wait.
And then last one is here. So this is 4 over 30. Then you can plot the flow. Okay. Okay. Now we have 3, right? 3. So to get the final one, meaning that for each of the recall, you need to add up all the recall at 10, uh, add up all the position at recall 10, then divide by 3 lah, kan? And so on until you get the 100th recall. So you add up all and you divide by 3. Okay, now we look at the single value summary. Let me erase this one. So if we know that this is now when we compute the recall and position, we are looking at the relevant document only, right? So the single value summary, normally we are looking at whichever position that we have. So for example, if we are here, so what is the recall rate here? And we are at the 10. So this is position 10. So the, the call. Normally we measure the position here. So what is the position here? 3/10, right?
3/10. Yeah.
Okay, what is the position over
3/11.
here?
Oh, 3/12.
Yeah. So this is what we call the single value summary, where you can pinpoint at any position, can pinpoint at any position, so that you can get the position value there. So if we go back to here, so single value summary. So basically, we are looking at a single position in the list of record or list of document given to you. So if we have, for example, position at 5 or position at 10, so we are looking at the 5th document or the 10th document. So if we something like this, so for example, we want to have the position at document 5, so which is here. So basically, it's 2/5, right? So if we are looking at the position for this position, it will be 4/10. So this metric provides an early assessment of which algorithm might be better compared to the other. So this is single value summaries. Okay. Now we going back to, okay, how do we actually measure the area under the curve? So we will need to look at this one, this mean average precision. So basically, okay, they are looking at number of query here. Okay, they also looking at the precision for each of the document that we have, that particular query that we have. So for example, go over the example here. So for example here, this is only for query 1, okay? So this is only for query 1. So for query 1, so whichever which is not 0, we'll take all of them. This is 0. So this is basically all this. So we add up all the value plus the 00 here, and the 10 here referring to relevant document. Not because they are 10, They are looking at the number of relevant documents. So this QJ is referring to number of relevant document for query J. So remember tadi tuh kita punya query 1 to ada 10 document, right? Yang relevant. So that's why we have 10 here. And this is the map. So that means area under the curve here is only 0.28. So what we want to do is we want to have 1. Total is 1 here. So the higher the map, better is your retrieval accuracy. Okay, coba kita tengok another example. Okay, so suppose we have this. So we have 5 relevant documents, and these are the position that is presented to you, and we compute the recall and precision. Okay. So what happens is when we try to compute the map, so basically we are adding up the position value only. So we have this. So let me finish this one first. So what is the map for query number 1? So basically we just add up all this and divide by, and then for this one we just add up all this 0.5, 0.4 and 0.43 and divide by 3. So we have the map for query 1 and we have the map for 2. So what is the overall map? So based on this formula, so basically we are looking at divide them by number of query. So in this example, we have number of query 2 only. So query 1 and 2. So basically we add up this and then divide by 2. So remember that each algorithm or each IR system that you have to test them using several query. So individual query will have their own map. So in order to compute the overall map, you need to add up all the map for each query divided by number of query that you have. Okay. Okay. Talking about precision and recall, these are two different metrics. Okay. So what they want to do is they want to combine these two into one formula. So they call it measure. Um, I'm jumping to the next one, which is this. Yeah, which is this one. Okay. Let me start this one first. So this F measure is basically combining the recall rate and also the precision rate in one formula. So by having this, we will be able to summarize lah. So if this is 1 and this is 1, then you get 1 lah. So the F measure is a single measure that combine both recall and precision. So you don't have to pening lah. Okay, so the F measure can summarize the overall performance of the retrieval using the recall and precision that they have. Okay, so let me go back to Bustan sekejap. Okay, we have also this R precision. Okay, so the R precision is used to compare between two query. Okay, so let R be the total number of relevant document for given query. Okay, the idea here is to compute the position at the R position in the ranking. So R position in the ranking. So that means this is the R position lah. R document. For the query one, the R value is 10 and there are four relevant documents at the top of the document. So this is based on query number one. So for that reason, the R position value will be 4. So if we compare these two, okay, so this is for two algorithm. So what we want to do is, okay, for the query number 1, 2, 3, 1, 2, 3, 6, 7, 8, 9, 10, algorithm A is better than algorithm B. And for query number 4 and query number 5, algorithm B is better than algorithm A. Okay, so this is B, this is A. So this is how we use the R precision in order to compare two algorithm. We can specifically say for which algorithm, no, for which query that they are good. So must have several query lah, in order to test this one. So because they are looking at the R precision, the R here referring to the R position of the document in the ranking. Okay, let's go to this one. Go back to this one. So let's do some exercise. Okay. So they ask you to find what is the position at document 5 and document 10 for query number 3. For query number 3, where are you query number 3? This query number 3. So what is the position here? We change color. So what is the position at document 5? And what is the position at here? So the position here is 3 over 10. This one is 2 over 5, right? Okay. So that is the answer lah. So the position document 5 is 2 over 5 and the position at document 10 will be 3 over. Okay. And they also ask about, okay, what is the map for query number 3? What is the map for query number 3? What is the map? So we need to know what is the position here. What is the position here? This is and 5, right? What is the position here? This is and 5. What is the position here? This is 3 over. The position here will be 4 over 13. So the map will be for this query 3 will be 0.5 plus 0.5 plus 3 over 8 plus 4 over 13 divided by how many?
Level.
Divided by 4, right? So this 4 referring to here. So that is the map. So if we go back to here, What is the F measure for all? Now, what is F measure at position 5 for query number 1, query number 2, query number 3? So here you should have um, three answers. So this is for query number 1. For position 5, 1 over over plus 1 over. So you need to look at what is the recall and the position at position 5 for query number 1. So we can look at the graph pun boleh lah. So for query number 1, no. Yeah. So what is the recall? The recall is 1 over 10. The position is
1 over 5.
5. So recall 110 and position is 5. So the recall is 1 and this is what tadi tu? 1 over 5, right? So 1 over 5 is 0.2. So this is equivalent to 2 divided by 10 plus
3.
5. So this is 2 over 10, right?
So 15. Yes.
So the value will be um,
0.13.
0.13. Okay, so the idea is to maximize your recall and also the positions where the whole thing will go to. So the F measure for Q1 is lower. Okay, let's take a look at Q number 2. Oh, yeah, Q number 2. So this is at position 5, Q number 2. This is 2, 1 over berapa. So query number 2, we have this one. And this is 1 or 2. This is 2. Yang tadi tu we take the query number 2 pula. Okay, let's take a look at query number 1. Query number 1 here is, and we are here, so the recall is 2 over 10.
2 over 10.
Position is
2 over 5.
yeah, so 2, 10 and 2, 5. Oh, so for query number 2, no, query number 1, query number 2 just now for the 5 is 0.13, right? For query number 1, so 2 divided by the recall is 2 over 10, right? Plus the position is 2 over 5. So what is the value here? This is Lebih kurang nggak? 2/5 is 0.4. Coba lagi.
0.26.
So 2 divided by 7.
2.5.
Betul?
0.26.
Ya, 7 lah kan? So that
Yeah.
the F measure for query number 1 is better than compared to the query number 2. Okay. So today you learn how to use recall and precision to plot the precision and recall. You learn how to measure map. So the map can be used to assess the quality of the information retrieval and also compare. And you also learn the F measure, and you also learn the single value summaries. Okay, I think that's all for this chapter. So very short. We have a lot of information to digest. Yeah. Any question?